Today, we're spotlighting a challenge: internal corrosion inside a high-pressure gas injection network that's central to a major enhanced recovery operation. Now, this isn't your typical pipeline system. We're talking about a complex grid of pipes, 5 compressor stations, and 125 gas injection points, all working together to push gas exactly where it needs to go. When it's running well, it's efficient, it's powerful. But systems like this don't stay safe without attention. That's where this engineering assessment comes in. The focus? One specific high-stakes issue: the risk of internal corrosion. And the tools used? Next-level tech. We're talking PIPESIM and OLGA-S, simulation software that models how gas and entrained liquids flow through every inch of the network. It's like getting a pipeline X-ray. You're not guessing where water might be pooling, you're simulating it. And that matters, because water, that's the enemy. When it pools, it creates a corrosive environment, basically a low-key acid bath, chewing through your steel from the inside out. One of the standout tools in this report is QIC Assess, Quantitative Internal Corrosion Direct Assessment. This isn't broad strokes, it's targeted, section by section, data-driven, no digging required. And guess what? Out of the entire network, just one section flagged elevated risk. One spot. But it's a big deal. Why? Because modeling showed 16.7 barrels of water pooling there. Let's break that down. As gas travels, velocity in that segment drops. Water begins to condense, it settles. And now, you've got corrosion on your hands. If left alone, it could breach the pipe wall in under a decade. So, what's the move? The report recommends volatile corrosion inhibitors, or VCIs, dosed at compressor stations, traveling with the gas. They vaporize, dissolve into water, and form a protective film on the pipe wall. Smart, right? But even with VCIs in play, Section 10 keeps holding water. So why not stop the water from forming at all? That's where the engineers get tactical. Using OLGA-S, they simulate changes to operating pressure and temperature, tweaks that shift phase behavior and keep more water in the vapor state. Less condensation, less pooling, lower corrosion risk. Because here's the truth, VCIs are great, but they treat symptoms. What if we could prevent the condition entirely? That's the magic of simulation. You don't shut down, you don't guess, you model, you test, you optimize, before touching a valve. And that's your takeaway. Corrosion control is not luck, it's precision. Know where the risk lives, understand why it exists, and choose the right tool, whether that's chemical, operational, or design-based. This report? It's a blueprint for proactive, intelligent, field-ready corrosion management. Thanks for listening.